The universe is not just expanding, it is accelerating. This discovery shocked scientists when distant galaxies were observed moving away faster over time. The cause of this acceleration is called dark energy, a mysterious force that fills all of space. Though invisible and poorly understood, it dominates the universe. Some theories suggest that dark energy may not only shape the cosmos, but one day destroy everything within it. Dark energy makes up nearly 70% of the universe. Unlike gravity, which pulls matter together, dark energy pushes space apart. It is not localized in objects like stars or galaxies, but exists everywhere, stretching the fabric of spacetime itself. The more space expands, the more dark energy appears, making its influence grow stronger with time. At present, dark energy is relatively gentle. It slowly increases the distance between galaxies, causing the universe to expand at an accelerating rate. This process is so gradual that it does not affect structures like galaxies or solar systems. Gravity still holds these systems together for now. But if dark energy changes, everything could be at risk. One possible future is the Big Rip. In this scenario, dark energy grows stronger over time, eventually overpowering all other forces. First, galaxies would be torn apart as the expansion rate increases dramatically. The gravitational bonds holding them together would no longer be enough to resist the stretching of space. After galaxies dissolve, the process continues at smaller scales. Star systems would be disrupted as planets lose their orbits. Stars would drift away from each other, no longer bound by gravity. The night sky would grow empty as familiar cosmic structures disintegrate under the influence of dark energy. As the Big Rip progresses, even individual stars would be affected. The force of expansion would overcome the gravity holding stellar material together. Stars would be pulled apart, their plasma dispersed into space. The universe would lose its primary sources of light, fading into darkness. The destruction would not stop there. Planets and solid matter would begin to break apart. The forces that hold atoms together, such as electromagnetism, could eventually be overcome. If dark energy becomes strong enough, matter itself would be stretched and torn into its smallest components. In the final stages of the Big Rip, even atoms would not survive. Electrons would be pulled away from nuclei, and subatomic particles would separate. The structure of matter would collapse completely. The universe would become a chaotic sea of isolated particles drifting in an ever-expanding void. Time would also be affected. As expansion accelerates, events would become increasingly disconnected. Regions of space would move apart faster than light can travel, meaning no signal or interaction could ever bridge the distance. The universe would fragment into isolated pockets with no communication between them. Dark energy could even affect spacetime itself. If it continues to intensify, the fabric of space might stretch beyond stability. Distances would lose meaning as expansion becomes infinite in a finite amount of time. The concept of structure would vanish entirely. Some theories suggest that dark energy may not remain constant. It could evolve, weaken, or strengthen unpredictably. If it changes suddenly, the fate of the universe could shift dramatically from gradual expansion to rapid destruction. Understanding its true nature is one of the greatest challenges in cosmology. Observations of distant supernovae first revealed the presence of dark energy. These exploding stars appeared dimmer than expected, indicating that the universe's expansion was accelerating. This discovery reshaped our understanding of cosmology and introduced one of the most profound mysteries in science. Despite its importance, dark energy remains largely unknown. Scientists cannot detect it directly or explain its origin. It may be a property of space itself, or it could arise from unknown quantum fields. Until its nature is understood, predictions about the universe's future remain uncertain. If the Big Rip does not occur, dark energy could still lead to a cold, empty universe. Galaxies would drift so far apart that they become invisible to each other. Over time, the observable universe would shrink, leaving isolated systems surrounded by darkness. The idea that dark energy could end everything is both terrifying and fascinating. It shows that the universe is not static or eternal in its current form. Instead, it is evolving under the influence of forces we are only beginning to comprehend. Dark energy may ultimately determine the fate of the cosmos. Whether it leads to a gradual fading or a violent end, its influence is undeniable. Hidden in the fabric of space, it quietly shapes the universe and may one day bring about its final and inevitable conclusion.